Okay, welcome back. So this is segment 4 of section 1.1. This is probably the last segment. There's not a whole lot that I want to cover that's left here, but I mean these are some important concepts. Just so you know, I mean section 1.1, which is supposed to be kind of a review section, tends to be a little bit longer than other sections, just simply because I'm trying to catch everybody up from wherever they might be with their experiences in geometry, and just to remind people about some basic facts. We'll go back to some of these other facts about geometry in section 1.2, but for now, all we're really doing is we're defining sort of the framework in which we're going to work, and also some of this stuff about different units, which I mean we kind of space that along. We really get into units a little bit more heavily in chapter 2, but for now it's just something to kind of it's an easy task, so it's simple enough to do it here. So let's try to finish out the rest of this this section. I think we are now on page 9. And we had done 3 things. We had talked about how to add and subtract angles that were measured in degrees, minutes, seconds. We had shown how to convert from decimal degrees to degrees, minutes, seconds longhand. I mean, most calculators will do it automatically. And then also how to convert from degrees, minutes, seconds to decimal degrees, also longhand, which are skills that you'll have to pick up, even though they may not be like a huge aspect of this course. It comes, especially for those that might be entering into an engineering or engineering technology field, those skills are paramount. If you're not really going to be going down that road, that's fine, but it's part of the course content, so we end up testing everybody on it regardless. Okay, so a couple more definitions. 2 angles are said to be coterminal. And there's the term, coterminal, if their measures, their respective measures, differ by an integer multiple of 360 degrees, or complete revolution is basically what's going on here. Now, and just a quick reminder, an integer is a whole number. That's kind of a little loose terminology. Whole number that's either positive, negative, or 0. Obviously, an angle is coterminal to itself. But if you had a situation where maybe you know, you're trying, and there's reasons why these coterminal angles are important, because it turns out the trigonometric functions of coterminal angles result in the same value. So being coterminal is basically a way for you to say, well, it doesn't really matter. If I'm trying to find a trig value, it doesn't really matter how many times I've gone around the circle. It's only its final position that really makes a difference, or where the sort of orientation of the terminal ray is the only critical thing. But just as an example, here's an example of some coterminal angles. Maybe an angle that measures 72 degrees. This is coterminal to one that has a measure of 432 degrees. It also happens to be coterminal to one that has a measure of minus 288 degrees. And you can verify that these are different by multiples of 360 degrees. I think in the textbook, there's maybe some problems where you do this kind of thing. They'll give you a measure of an angle, and they say, find one positive and one negative coterminal angle. And by that, they don't mean to use the angle itself. They want some other one. So there's some examples of that in the textbook. Now, here's something to note, and this is kind of a critical fact. All angles are coterminal with an angle, and we'll just say theta, whose measure is between 0 and 360 degrees. And we're including 0, but not 360. Because notice those two are actually coterminal to each other. What this is saying is that you can construct, if you had a coterminal, if you had an angle that was like outside of 0 to 360 degrees, you can always construct a coterminal angle that's between 0 and 360 degrees, which is the most natural way to think about it. Single, not any multiple laps around the circle in terms of rotation. And it's usually going to be the case that we're interested in this number that's between, possibly equal to, but between 0 and 360 degrees. And lots of the problems are geared towards finding that angle as well. So if you had, for example, if the angle is 432 degrees and you needed to find a coterminal angle between 0 and 360, well, the answer would be 72, right? So that's just kind of a note. Sort of a side topic, an angle is said to be in standard position if it's, now here we're gonna add in a coordinate axis, right? Like an XY plane or something, like if you're more familiar with algebra. An angle is said to be in standard position if its vertex is coincident with the origin of the XY plane and its initial ray is coincident with the positive x-axis. So, I mean, that's, angles just kind of exist out in space with any kind of orientation or whatever else. They don't really have a preferred direction or orientation. What this is saying is that if we happen to create a coordinate system and line it up with the vertex and make sure that the initial side is coincident with the x-axis, this is how we're going to standardize these trigonometric functions by saying, okay, well, it's going to be related to certain parts of this sort of arrangement, which we can now calculate x, y coordinates, that sort of thing. And this is sort of the setup or the lead into this, and also gives us a way to talk about some universal sorts of ideas. But basically, I'm going to draw you a little picture. If you've got, let's say you've got a, you know, some sort of an angle out here in space somewhere, right? Notice it's not horizontal because that's kind of what's trying to be indicated here. If this is your angle and this is, say, your initial side, then we can in some sense create a coordinate system where this is the positive y-axis, this one has to be the x-axis, and now this angle is now in standard position. And its measure is going to be sort of this, or possibly rotate backwards, or maybe go around 16 times. But we have what's going to become critical is not so much the measure of this angle, but the position of this terminal ray with regards to this sort of imaginary XY plane that we've put on top of things. So that's kind of a little setup for what's happening next. Now, given that reality, we can start talking about, again, a couple different kinds of angles. So this is now, I think, page 10. Okay, so an angle in standard position abbreviate that, is said to be a quadrant angle if the terminal ray or the terminal side is coincident with either the positive or negative x-axis or y-axis. So that's kind of a long-winded way of saying that in some sense, the angle is coterminal with an angle whose measure is either 0, 90, or 0 degrees, 90 degrees, 180 degrees, 270 degrees, right? So those angles, those quadrant angles turn out to be sort of like some special cases for the trig functions which follow. And the strange thing is, maybe you're familiar with the term quadrant, which is the next thing I'm going to define, but it turns out that quadrant angles are not in any quadrant. They actually define where the quadrants are set up. So for example, if we had an angle in standard position that was coincident with the negative y-axis, so if this is our initial ray and this is our terminal ray, notice it's coincident with the negative y-axis. The measure of this is coterminal to an angle that's 270 degrees. We could also, if we measure it another way, maybe it's minus 90 degrees. There's all sorts of different possibilities, but this is a quadrant angle. There are actually 4 of them. Okay, so the next thing is talking about quadrants. An angle that is not a quadrant angle can be identified by its quadrant, which is just a weird, very weird construction of sentence. But I'm gonna remind you guys that you talk about quadrants in algebra class like exhaustively. So I'm gonna kind of draw a little XY plane here, X and Y, and the way to sort of identify this is, so if you're not a quadrant angle, which are only these 4 directions, but if instead you were somewhere up over here, if the terminal side was any angle between 0 and 90 degrees, this is over here in quadrant 1. Sometimes people use capital Q and a Roman numeral. There's other ways to do this. You can even spell it out, quadrant 1, Q, Roman numeral, or sorry, Arabic numeral 1. There's 100 different kinds, but the next quadrant in the counterclockwise rotation is 2. Counterclockwise from there is 3, and then counterclockwise from there is 4. So if you're not a quadrant angle, you're going to lie in one of these quadrants, right? So to recall this this coterminal idea, so there is an angle that's, no matter which angle you have, there is an angle that's positive measure between 0 and 360 degrees that's coterminal, and let's say theta coterminal. So if theta is between 0 degrees and 90 degrees, then the angle is called a quadrant 1 angle. Quadrant 1 angle. And there's a couple different ways to write that. You could do this, Q1, quad 1, Q1, Q1, quadrant 1, whatever makes you happy, just as long as it distinguishes that it's a quadrant and it's in quadrant 1. Now notice 0, if it measures 0, that's actually a quadrant angle, which is weird. Quadrant angles don't lie in any quadrant. they define the quadrants. And a 90 degree would also be a quadrant angle. So we kind of skip over the value of 90. So if it's between 90 and 180, then that's a quadrant 2 angle. Between 180 degrees and 270 degrees, it's called a quadrant 3 angle. And then finally, from 270 degrees to 360, it's called a quadrant 4 angle. And this is probably not something that's totally new to people, but just to be very careful, because what we're going to find is that when we start looking at the values of trigonometric functions for angles in these different quadrants, we come up with some rules for how to deal with them. And it actually has to do more with the application of their SIGN, whether they're positively valued or negatively valued. But anyway, so this is sort of the setup. We've defined a lot of stuff about angles, measurements of angles, some descriptive terms that are associated with them. And there's a number of what I would consider to be fairly easy homework problems associated with these ideas. Now, when we get into section 1.2, we're going to start looking at some geometric results, right? So basically, there are things that you learned about in geometry that's related to angles and triangles and some other stuff. There will be some additional definitions, but it becomes a little bit more associated, less with angles and more with sort of stuff involving angles. So I will see you in the next